Mm. Sorry. Gute. Sorry for that. But these cookies are really tasty. So sorry you can't taste them, but trust me, they're really good. But I will make that introduction really short because the video itself is long enough. I will show you how I use the dataset analysis notebook by Coqui TTS and to analyze my recording in progress dataset, and how I figured out to interpret the data or to fix some minor problems I had with running the notebook. So you enjoy the show, I enjoy the cookie, and we will see us after the video. With the things we have to do for every Jupyter Notebook usage. So what I have prepared on my local system, let's open the Finder in my Documents, a YouTube subfolder, and in that specific subfolder, my LJ speech directory based Thorsten neutral dataset. So I open it up. It is containing a metadata CSV, some README stuff, and the WAFs directory with all the files. So that's all in my Documents YouTube folder right now. So let's minimize that for the moment and open Coqui TTS repository on GitHub. So let's go to GitHub, Coqui TTS. I'm right, its latest version is 0.3.1, as you can see in that area here. So what I will do now is I will create a new Python 3 virtual environment, clone that tag 031 by Coqui text-to-speech, and then we'll take it from there. So open a terminal. Let's make it a little bit bigger. Go to our Documents, YouTube folder. Just to show it, there is that dataset in. Let's run Python 3 and virtual environment. In my next videos, I will not show you that pre-processing or preparation tasks. So that's just for today's video. The next videos on the Jupyter notebooks included in Coqui TTS repo will not include that setup, that basic setup. So we now have the typical directory structure created in a Python virtual environment. And as always, let's activate it by calling source bin activate. You can see we are now in that YouTube virtual environment. And now let's clone that repo with the branch or the tag version 031, and let's copy that clone URL. Let's run it. While this is cloning, let's take a look in the repo. We have in the main directory that notebook subfolder, and that's the part where I want to take a look today. So that's the notebooks, and there in special the dataset analysis directory, because I'm currently in the process of recording a new neutral Thorsten dataset, and I would like to check some of these notebooks on my work in progress dataset. So let's check if cloning has been finished. So yeah. So in addition to my dataset directory and the stuff from Python virtual environment, we now have that TTS folder. Let's go into that. What I'd like to do first, before doing some special TTS stuff, I would like to update some basic packages. So let's call pip install the package manager itself, setup tools and wheel -- upgrade. So I would recommend doing that so you have that basic components and modules in the latest stable version. So once this is done, and we are now in that cloned TTS subdirectory, let's call pip install -r the requirements txt that is included by the Coqui TTS repo. That might take a second or two. So all the dependencies are now going to be resolved. So process is finished. So we have now all resolved the dependencies, written the requirements txt in our specific virtual environment. Let's now call Python 3 setup py develop. So, as you can see, by the end of that output, we now have built our module, our TTS module in the specific cloned version. We can double check that by entering Python package manager list, grab TTS. Yeah, and we see we have installed our TTS package in the specific version. Let's do another check and grab for notebook. As you can see, we do not have the Jupyter Notebook package installed, and that is required to run that Jupyter Notebooks from the dataset analysis notebooks subdirectory folder structure on our local system. So let's install that simple package called notebook. So finished. Now we have set up everything, hopefully set up right. So what we can do now, let's go into our notebooks subfolder, check the directory. So we are in the documents YouTube TTS notebooks folder, which is mapping that TTS notebooks folder. Now let's minimize that and make this one a little bit bigger. Let's call Jupyter Notebook just in that specific directory. And if things are going right, our browser will open. Yeah. And we now have a local instance of the Jupyter Notebook environment. And you can see these are all the files in that directory structure. So let's go into dataset analysis. And as always, I am not a professional TTS guy or whatever. I just try to find my way through and share my experience or my thoughts on that journey with you. So if you think or know I'm talking weird stuff or I'm saying things that are wrong, please correct me in the comments or let me know. So I am always happy to learn new things and to improve my knowledge. So please let me know if there's something horribly wrong. So let's start with the first notebook, that's the AnalyzeDataset notebook. Open that one up, and that is the Jupyter notebook as it's in version 0.3.1 included. So the obvious thing is the path. Greetings out and shout out to Erigol, but that path will not work. So let's clean that and open a new window, because the Jupyter notebook is a foreground process, so I need a new command line. Let's go to my directory, documents, YouTube, and then my dataset directory. So you need the path where it's the LJ speech file directory structure in my case. So copy the file path with the metadata CSV in and the WAV subdirectory. So print the directory and let's copy it here. And let's run that. So that's simple and it worked. So let's run the next step here. On my first steps and tests, I run into an issue that a PYTZ dependency could not be resolved. But looking into pip list package lists, I've seen that specific package, so I had no idea why this is not be found. And the simple solution was to install a package called IPY kernel. So if you encounter a similar problem, maybe check if IPY kernel might help resolving that. So as you can see, the number has entered here, so it's working. Now we have a data path, and that's the same as above. And as I have not a list of different data sets, I can reduce that list or to remove it from being a list to just a string. And in my case, it's just the metadata CSV. Keep that numproc variable in mind. I will not change it right now because I would like to show you the issues I've run into. But we will come back to that variable later on. So let's run it. So if we now run the next part, we will get an error. I give you a second to find out why. Ding, 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 dee, 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 dee. So, okay, oh God, sorry for that. Probably you got it already. Here's the mail apps written, but my dataset is not a mail apps structure. It's an LJ speech structure. But let's just, for the fun, let's run it that way, and we will receive 0 found audio files, because the file structure differs from mail apps to LJ speech. So no files will be found. But that's easy to fix. Let's change it to LJ speech. Run it again, and ta-da! Now we have found all WAV files. Let's run the next steps. Check WAVs if exists. So, okay, good. All files from the metadata CSV are found in the WAVs directory. So if there would a file be missing, the path will be printed out here. That's a nice one. Show duplicate items. Let's run it. The output looks weird, but the information is still helpful. So what we see here with that count bigger 1, files, or not even files, but phrases that are recorded more than once will be printed here. So as you can see here by the file structure in that LJ speech directory structure, the file names are unique identifiers. and duplicate file names in one directory will probably not work. So let's just take a look to that metadata CSV file. Let's open it. Where is it? Open with my editor. Let's search for that file name, and we will see a duplicate entry. So obviously it's just once in the file system, because there cannot be duplicate file system file in the one directory, but we find that it's duplicate in the metadata CSV. Just to check it again, let's take that one. As you can see, found 1 out of 2. So, and that's always the same text in my case, and it's the same file name. So probably I can remove these few items, duplicate items from the metadata CSV file. Then let's run the next step, and we get an error. Gladly, I encountered that error previously, so I can hopefully show you a workaround or a solution that at least work for me. So when I try to run it, I run into that exception, and it's repeated several times. Cancelled. So, and as you can see here, it's spawning a pool worker process, and as you can see in the code above, that pool magic is in case the numproc value is not set to 1. I have no idea if this is a good way to change it, but at least it's working for me. So I set that numproc from 8 to 1. Execute it again. And if I now run that step again, it will not run that code, it will run that code without that pool magic, which seems to produce an error in my case. So let's run it, and great, process is working. Beautiful optical line break. So finished. Next is counting the words in the dataset. Let's check it, and I have 16,754 words. And that confused me, because I thought I have 8,000 recordings. If I have just 16,000 words, my average phrase would have 2 words, which is not the case. So I checked it by running word count metadata CSV, and as the wc word count command is putting output on the counted lines and words and so on, I've seen it's definitely more than 16,000 words. So I think that code block is just counting unique words. So I think I have recorded right now around 16,000 unique words. Let's run the next step. That's fast. So it's just doing some compute stuff. It's not printing out any values right now. So let's run the next. And here we have again an output, and we will see some results here. What is that crazy output about? It's obviously a list, but the first value seems to be the file name. Okay. The second value is the text taken from the metadata CSV. Okay. And the next one is the length of the text. 3 characters, 1, 2, and the dot, 3. Perfect. I was confused what that is. It's looking really important, but I have no idea what that crazy output is. But I found it, or I've seen the code snippet where that value is being set. So it is, let's go a little bit above, we have that load item function here, and that is filling that list with the file name, the text length, and the audio. And the last column or the last value is the audio length. So that magical output string seems to be part of the raw audio. So let's go back. So we see the file, the text, the length of the text, part of the audio, and the length of the audio. And as it's a value 0.79, 0.7, 0.82, 1.0, whatever, all values surprisingly are less than 2. So, and as it is the duration of the audio file, it's just showing us which recordings are less long than 2 seconds. Now, that's okay for these short phrases as there are here. But if you have a longer text and the spoken audio is less than 2 seconds, then maybe it's worth a look if you have a broken recording. Now it's computed some seconds per character without any output, and then we have a mean or a standard abbreviation or derivation, not sure, but that NP is the NumPy include. So let's check the NumPy mean. Agree. NumPy mean. Compute mean, sounding crazy, but probably is important. And we have NumPy std, compute the standard deviation along a specified axis. And wow, that is really sounding crazy. And I think people that are way smarter than I am know what that means. So respect for you guys, crazy. I have no idea, but it's sounding really important. So let's close that quick. So, but I think a less value means that all recordings are in a consistent pace, or so please correct me in the comments, but I think a less value is a good one. Then we have next step. We have again the same output, file, text, length, audio, and the audio file length. But why are these files printed here? It's just if you have any recordings that are too fast or too slow, so the derivation or derivation, I have to Google that and to learn it, that value is too high or too or less than 0.39, whatever it means in detail. I have no idea right now, but maybe it's worth a look to or hear that files, if they are broken or too fast, too slow, whatever. I think it's a good idea to check that. So what we now have, let's go to the plots. That output is, as you can see, the text length versus the mean audio duration or the median audio duration. So I think, as obviously on the lower axis, we have the length between 0 characters and 160, which is the longest characters I've recorded so far, and the duration from 1 second up to 8 seconds. So obviously, the longer the text is, the longer the recording took, or the audio is. And as it's a nice line, the speech pace, so the spoken characters per second, seems to be good. Obviously, on longer phrases, it's harder to keep the speech pace, but it's still, I think, it's an acceptable graph. Let's check that. The text length versus that standard magic. And I think I would check or try to find out these dots that are apart from the main group. So check these recordings. Next thing, we see the text length, and again between 0 and 160 characters, and the number of instances or recordings spoken in that specific length. You can see that the text phrase around 40 characters is spoken really or often, up to 300 times. Next is just computation, and we now have the most spoken words and the less spoken words. So just the top results, not all results, of course. So the typical German articles, which is the in English, is in German die, der, das, are probably the most, and there are the less words. I can check in the next step a specific word. So let's check if the logic above is working. When I try to get the number of D recordings, hopefully it should return that 1862. So, okay, so if you're searching for a specific word, you can do that here, but probably that is easy to do here. We have it more often because I have it honestly, I have no idea. 4,700 is, even if I divide it with 2, is more than 1,800. Okay, get it. So I was really confused now, because that D is not just included in the D. When I search in my editor, it's just in diesem, so it's obviously more. And as it's written twice in that LJ speech metadata structure, it's duplicate value and honestly that which is not D. So, whoa, that confused me. And the last thing will print a frequency bar, but it's taking longer time as it's written here in the comment, but it's not really helpful, so I skipped that. So that's it for the AnalyzeDataset notebook. Hopefully I will find some time to make a video on the other notebooks that are provided by Coqui TTS. And that's it for my live screen sharing session. So that's been my video, my technical walkthrough. I hope you found it helpful, and as I've said, I'm not an expert, so please correct me when I said anything wrong, or so give me any feedback in the comments. Your feedback is highly appreciated. So that's it for today. I will enjoy the last piece of my cookie, and then we'll check if I find another one. And while I'm doing that, I wish you a nice and pleasant rest of the day, and bye bye.